This is Lavnika, working as assistant professor in Ratnam Technical Campus. Today we are going to learn about dynamic memory allocation. What is dynamic memory allocation? Dynamic memory allocation allows a programmer to allocate, resize and free memory at runtime. The memory is allocated on the heap area instead of stack. What is heap area? Heap area is a dynamic memory allocation. Dynamic memory allocations. Stock area is static memory allocations. In dynamic memory allocation, array size can be increased or decreased as needed. And in dynamic memory allocation, memory persists even after the function that allocated it finishes, allowing the function to return pointers to it. This is the different from the stock allocated variable, and it is not safe to return the address of those variables. There is the four functions. First one is malloc. Malloc stands for memory allocations. Malloc stands for memory allocation. This function is used to allocate a single block of the continuous memory on a heap at runtime. The memory allocated by malloc is uninitialized, meaning it contains the garbage value. Second function is cloc. Cloc stands for the contiguous allocations. This function is similar to the malloc, but it initializes to the allocated memory to 0. It is used when you need memory with the default 0 value. And then third function is free. The memory allocated using the functions malloc and cloc is not deallocated on their own. The free function is used to release the dynamically allocated memory back to the operating system. It is essential to free the memory that is no longer needed to avoid the memory leaks. And then fourth function is realloc. Realloc function is used to resize the previously allocated memory block. It allows you to change the size of an existing memory allocation without needing to free the old memory and allocate the new block. Suppose we initially allocate the memory of 5 integers, but later need to expand the array to hold 10 integers. Means we can use realloc to the resize the memory block. See the example program. First, initially we allocate the memory of 5 integers using the keyword malloc. See the syntax: int star ptr equal to int star malloc 5 star size of integer. Okay, then we need, imagine we need 3 more integer size elements. Means we need to store 8 elements, so we can reallocate to store 8 integers using the keyword realloc. See the syntax: ptr equal to int star realloc ptr comma 8 star size of integer. Got it? Then assume we only use 5 elements now. Then we can use keyword realloc to shrink the array back to 5 elements. See the syntax: ptr equal to integer star realloc ptr comma 5 star size of integer. So finally we can free the memory when done, like using the keyword free of ptr. Finally free the memory once it's done. Okay. Next, difference between the malloc and cloc. Malloc is a function that creates one block of memory of a fixed size. Cloc is the function that assigns a specified number of blocks of memory to a single variable. Malloc takes only one argument. Cloc takes 2 arguments. Malloc is faster than cloc. Cloc is slower than malloc. Malloc has high time efficiency. Cloc has low time efficiency. Malloc is used to indicate memory allocation, but cloc is used to indicate the continuous memory allocation. There is a difference between the syntax and syntax. What is the difference? There is 2 arguments in the cloc, that is number and the size. In malloc only size is required. Malloc does not initialize the memory to 0, but cloc is initialized to the memory to 0. Malloc does not add any extra memory overhead. Cloc adds some extra memory to overhead. What are all the issues related to the dynamic memory allocation? As useful as dynamic memory allocation, it is also prone to errors that requires careful handling to avoid the high memory usage or even system crashes. Few of the common errors are given below. What are all the errors? Memory leaks, dangling pointer, and the fragmentation. Memory leaks. Failing to free dynamically allocated memory leads to memory leaks, exhausting system resources. Using the pointer, what is dangling pointer? Using the pointer after freeing its memory can cause unidentified behavior or crashes. Fragmentation, what is fragmentation? Repeated allocations and deallocations can fragment the memory, causing inefficient use of the heap spaces. And then second topic is singly linked list. A singly linked list is a fundamental data structure. It consists of nodes where each node contains the data field and the reference to the next node. It is the linked list. The next of the last node is null, indicating the end of the list. Linked list support efficient insertion and deletion operations. Creating an example linked list size of 3 to understand working. First, create the first node. Allocate the memory for the first node and store data in it. Mark this node as head. Second, create the second node. Allocate the memory for the second node and store data in it. Link the first nodes next to this new node. Okay. Third one, create the third node. Allocate the memory for the third node, store the data in it, link the second nodes next to this node, set its next to null to ensure the next of the last is null. Okay, see the example program. First, creating the node like data and node pointer next. Constructor to initialize the new node with data. Node integer. A new data is given as a integer. This data equal to new data. This arrow next equal to null pointer. Okay, this is the linked list node structure. See the main function. Create the first node, head to the list. Node star head equal to new node of 10. Second, link the second node, head to the next equal to new node of 20. Third one, link the third node, head to the next equal to new node of 30. Link the fourth node, head to the next equal to new node of 40. Printing the linked list. It is in the while loop. Okay, so we are going to print the list and then output will be the 10, 20, 30 and 40. Then third topic is typedef keyword. The typedef is the keyword that is used to provide the existing data type with the new name. The same typedef keyword is used to redefine the name of already existing data types. When names of the data types become difficult to use in programs, typedef is used with the user-defined data types which behave similarly to defining an alias for the commands. Okay, see the program, example program. So there is a type of keyword struct for the keyword structure, and then students. We can get the input as the character name, character branch and then ID. So we can use the STU as the type of data type. So using the STU we can get the input as the user defined data structure. So STU, yes, S is the variable of the stu. Now string copy s dot name geeks, string copy a dot branch CSE, s dot ID number. So ID number as the 108. Then we can print name, branch and ID. Explanation in this code. The typedef is used to define an alias name for the typedef structure. Typedef used as the define an alias name for the structure, declaring the variable of the structure. Then it enhances the code readability. Okay. Then union. A union is the user-defined data type that can hold different data types similar to a structure. Unlike the structure, all members of the union are stored in the same memory location. Since all the members share the same memory, changing the value of the one member overrides. Unlike the structures, all the members of the union are stored in the same memory location. Since all members share the same memory, changing the value of one member overrides the value of the others. Union members can be accessed using the dot operator. Example, u dot member. Unions are useful when you want to save memory by storing different types of data in the same memory space. Size of the union. The size of the union will always be equal to the size of the largest member of the union. All the less sized elements can store the data in the same space without any overflow. Union declaration. Union declaration. A union is declared similar to the structure. Provide the name of union and declare the member variable. Example program. Here we declare the union as student. Roll number. We get the roll number, height and the character of first letter. Declare a union variable as union student data. We can get the data dot roll number equal to 21, data dot height equal to 5.2, data dot first letter equal to n. The output is 21, 5.30 and n. Then what is the difference between the structure and the union? A structure is a user-defined data type that groups different data types into a single entity. The union is a user-defined data type that allows storing different data types at the same memory location. A keyword struct is used to define the structure. The keyword union is used to define the union. The size is the sum of the size of all members with padding if necessary. The size is equal to the size of the largest member with possible padding. Each member within the structure is allocated unique storage area of location, but in union, memory allocated is shared by individual members of union. No data overlap as members are independent. No full data overlap and then share the same memory address. Individual members can be accessed at a time. Only one member can be accessed at the one time. Thank you all.